Either one, I just want you to remember that they effectively mean the same thing, right? So, y equals mx plus b and y equals a plus bx. Those are exactly the same equations. How do we recognize in this equation that they're linear equations? What do we see there? Let's say again. Something with the x, there's something else that I need to talk about. Constant what? Additive rate of change. What were you saying with it, Marcus? Okay. I think you said a relationship, right? No? I don't know what you said then. Okay. I can't help if you're not gonna say it. But constant additive rate of change. So remember, if we are repeatedly adding, someone did say this earlier, what operation are we gonna see? We're gonna see what? Multiplication if we have constant addition, right? Okay, thank you. So please be aware of that. Whenever I see, hey, that's linear, I'm thinking about that relationship. So remember, my additive rate of change is right here. This value is the what? What is the A here and the B here? That's the y-intercept. You got to keep that in mind. One thing that I should have put into the bell ringer is this. And y equals, one of these is linear, one of them is quadratic.
Oh, not.
Eyes up here please so we can learn, pay attention. Which is equation 1 or equation 2 linear? Why is it 2? Because what? What about the exponent? Be careful, we do want to remember there's always if there's no exponent written, it's an understood what? 1. Right? We talked yesterday about a second degree polynomial with quadratics, right? Meaning, what do I mean by second degree? The highest exponent is 2. So that's second degree. You notice how these equations look very similar, right? But this has a square on it indicating we need a second degree polynomial. Here though, all I have is an exponent of 1 with simple multiplication. What is the constant additive rate of change for this second equation? Right, this is linear. What's going to be the constant additive rate of change? What am I repeatedly adding by? 5. How do I know I'm repeatedly adding by 5? And that's not this plus 5. Remember. Yeah. So remember, how many times is this plus 5 happening? Just once. How do we see repeated addition? That multiplication, right? That multiplication indicates a constant additive rate of change. Guys, it's hard to pay attention if our eyes are not up here. Constant additive rate of change is through that multiplication. We've got to keep that in mind. Okay, second question was, what's the equation you can use for exponential functions? And be careful, the most common answer right here, in fact all these answers, was A times BX. That's not exponential. Why not? Because the exponent, that x needs to be where? In the exponent. And we might have difficulty just putting that answer in, but we need to recognize that if it's exponential, that it has a variable exponent. So in this case, what type of rate of change do I have and what would be that rate of change? What type of rate of change do I have for the exponential, and what would that rate of change be? Constant multiplicative, right? Which of these would be my constant multiplicative rate of change?
The B.
The B, right? How do we know that that B is my constant multiplicative rate of change, Z?
Because we keep being multiplied.
Z, how do I know that's my constant multiplicative rate of change? Are you engaged in the conversation at all? Because when I looked, and the reason I'm calling on you is I'm not trying to be a jerk, but I need you to engage, and it looks like you're just kind of just staring off. You've got to be involved in this conversation if you hope to learn this. Can anybody help Z out how we know that that has a constant multiplicative rate of change by B? The exponent, because an exponent is what? Repeated multiplication. So Z, How do I know that b is my constant multiplicative rate of change? Dog, they literally just said it. You're just not even caring at this point, and I can't help you if you're not going to care. Can someone help Z out? And we're going to come back to it. Lily Kate. Okay, so that exponent. Why? We need a little bit more detail though. Why is that exponent telling us that's the multiplicative rate of change?
Being multiplied.
Being not just multiplied,
Multiplied.
but what does that exponent indicate? Not just multiplication, repeated multiplication. Guys, an exponent, specifically with a variable, is telling us repeated multiplication. So Z, how do we know that we're constantly multiplying by B? Huh? But what's telling us the repeated multiplication? The exponent that is a variable. Z, I care about you. I need you to engage in the conversation, okay? Alright. Guys, please hear me once again, because we are going through the motions at this point of walking into, and when I greet you saying, when you say I am capable. I'm asking you to do that because you are, all of you, capable of growing and learning. But what's going to prevent you from growing and learning? There's a few things.
Not engaging.
If you don't engage, if you're not a part of that conversation, it's going to be real hard for you to grow and learn. What else can prevent you from growing and learning in my class? Not taking notes. And because if you don't have notes, can you go back to those notes to help you study or complete problems in class? No. Guys, all of you are capable, but if you don't do the things necessary to be successful, you're going to put yourself into a hole. Alright? Taking notes, referring to those notes, those are going to be helpful to you long term. Alright, let's get started with today's lesson. Trayana, I didn't even see you come in. Good morning, Trayana. Do you have a check-in? Then I was just working and that's my bad. Alright, so good morning, Trayana. My bad. So, who else just came in? Well, you came back, because you just turned in your excuse. Who else just came in? There's multiple people. Mickey and Desiree, you came in as well, right?
Or a big fight.
Alright. Okay, yeah, almost everybody now. Just missing, oh, and Tevin, you came in too, right?
What you said?
So you were already, you gave me your pass. Alright. So, here's a couple of quick things we're going to do. I need to do a quick reminder of active collaboration. I'm not going to spend long on it, but I feel like some of us are forgetting the active collaboration, right? Jose already mentioned that in order to be successful in my class, you're going to have to engage. So let's look at what that means. Then we're going to do a couple of quick details on Venn diagram before we mostly work on linear and exponential functions and writing those equations. And then we'll get to the book for the back half of today's class. So remember, not engaging, that's that 0 to 2. If you're falling asleep, if you're staring off into the distance, you are not engaging, which means you're not going to grow and learn. Point blank period. You got to engage. The bare minimum, not even where you want to be, but the bare minimum in small group, what are you going to have to do?
Oh.
You don't have to talk in small group to get to that 3.
Take note.
In small group. So like when you're at the boards,
Oh.
you're going to have to what? You have to work on your assignments. Like you have to. Now to go from that 3 to that 3.5, that's still small group. So Tevin, what are you going to have to do in the small group to go from the 3 to 3.5? You're going to have to talk within your small group. You're going to have to actively collaborate. And I need y'all to hear me on this. One person should not be doing all the work on the board. I want you talking with each other to talk out your ideas and to think through, okay, so, all right, what type of function is this? What do we all agree? Okay, can we explain why? If you can't explain why, you don't have to write the why down, but if you can't explain why to each other, you're setting yourself up for failure on the assessments because You're going to have to explain y on the assessments. So I need you talking with each other to make sense out of, okay, what type of function is here? In the same vein, you're going to have to write equations. You can talk through with each other, okay, so what do you think this means? What is the y-intercept in this case? What is the slope in this case? So talk it out before you write it on the board. But I don't want to see just silent groups. That's not going to help you grow and learn. The more you talk about something, the better you learn it. Now don't forget during whole class discussions, right, to get a 3, because you have to do this to earn a 3, what are the 3 things that you could do during whole class discussions? Take notes. Pick up a pencil, guys. I cannot make that clear enough. Take notes. If you don't have notes, you can't really study. Someone even in my 3rd block yesterday was like, Mr. Kinney, I can't really do the homework assignment. Why not? Well, I don't really have any notes. I've been over it. We discussed it. You worked in small groups. We generalized in the whole class. You got to take notes. Or you can actively share thoughts or ask questions. And then 3.5, you got to work within your small group. To get to that 4 and 4.5, you're going to have to do how many of those whole class discussion things? 2, right? So you still have taking notes, asking questions, sharing thoughts. To get to a 4, you have to do 2 of those things, and you have to start talking. Guys, legitimately, I need you to think about this. In order for you to talk about something, what are you going to have to do with your brain? You're going to have to use it. You're going to have to think. That's the point. Now, if you are thinking, but it's silent, can I tell? I can't hear your thoughts. I assume you don't want me to hear your thoughts for a lot of things, because like you might be thinking mean things about me, weird things about each other, right? I get it. But here's the thing, like if you're not saying anything, I can't tell that you're putting your brain in gear. And you've got to think about these things to be successful. And then to move up to that 5, you have to be a leader within your small group. So, trying to think here. Let's just do a couple of quick ones. I am going to collect this on Thursday because I want you to have it to study for your understanding check tomorrow. And so I'll collect it on Thursday. All right. What's something? I'm just going to do one thing in each of these sections. We already pretty much filled out this centerpiece completely yesterday, right? Okay. Did we look at this overlap or this overlap?
The left one.
The left one right here? Oh, we did a little bit of both?
Yeah, we just did something right here.
We just didn't do anything here? Did anybody identify something that quadratic functions and exponential functions have in common, but linear functions do not? Something that...
They got curves?
Yeah.
Which representation are you referring to?
What you mean?
So what are the 5 mathematical representations?
You talking about the tablet thing and the graph?
It's tabular representations,
Graphical.
graphical representations,
Pictorial. Pictorial.
pictorial, verbal, and algebraic representations. Those are the 5 ways we can represent things, right? So I'm asking, when you say it's got a curve, which representation are you referring to?
Oh, the graph got a curve.
There we go, because remember, can you see that curve just in the equation?
No.
No, right? Can you see that curve in the table?
Nope.
No. So we want to note, graphically, both have curves. So that is something that they have in common. It's a telltale sign. But there is a separation between the two. When we talk about an exponential function, what does that curve look like? When we talk about an exponential function, what does that curve look like? Flattens out, so it's steep and then flattens out, right? That's called an exponential curve. Could you draw a quick sketch of what an exponential curve looks like? Okay? Could that give you a summary of notes?
Yep.
Guys, this, if you do this well, summarizes everything from linear and exponential functions and quadratic functions. It covers everything from the dream job salary task and the gold rush task, so you have all your notes in one single place to study from. And so what was the name of this, and for like if you're trying to justify something on the assessments, what was the name of that curve? Not this one. It's an exponential function, it's a curve.
What is that?
Exponential curve. It was literally called an exponential curve, guys. I know, it sounds crazy, but exponential and linear, those are pretty straightforward. It's called linear function because it's a line, right?
What's the other
called
one
an
again?
exponential curve. Huh?
What's the other one again?
You're talking about for the quadratic?
Oh, that's called parable?
What's it called?
What's the one that's called parable?
Parabola. Right?
I ain't
Specifically, does anyone remember what direction this parabola is? I'm missing a keyword. Concave down. This one is concave up, like a cup, right? So we have parabolas,
Oh, it's right here. I literally got it.
and we have concave up parabolas, we have concave down parabolas, right? We want to keep that in mind. Those are details that we want to add in. Does anybody have anything else they want to ask? Hey, does this accurately fit? So we have a little bit of extra detail. Go back through your notes. I will point out, you should consider algebraic, tabular, and graphical representations for all three of these. Identify where they overlap, and then identify where it's unique for that function. But does anyone have a, hey, Mr. Kinney, I put this in this section, but I'm not 100% sure.
I did have it, but they later lost my paper.
Oh, no, I found them.
Oh,
I'm sorry, I said that earlier and then I forgot to pass them out. Z, there's the notes you had. Cam's not here. David. Seven. Miracle. Jayla. Sanaya. Jaylin. Ewan. Okay, hey, really quickly, guys. I do want to caution you. Hey, pause really quickly and listen. I do want to caution you because I know it's very tempting, and I know students, especially my third block, did this. It's really tempting to Google stuff. But if you Google stuff, there's a lot of things that we have not covered. For example, I saw this on 2 or 3 people's Venn diagram. Have you ever seen me write this equation on the board?
No.
No. So does that make sense to put up there? No. That is the quadratic formula to solve a quadratic equation. We haven't started solving quadratic equations yet. So, huh? Eventually. It's way less scary than you think. Don't stress about things, guys, don't stress about things that we haven't learned yet. Now, hopefully you at least saw it in Algebra 1. If not, I'll teach it from the beginning. But that's a quadratic formula to solve quadratic equations. Don't write that stuff down. Just now, and this isn't to be mean to this person, it's just to point this out, I saw someone write this here. Which this is true, they're both polynomial functions. Have you ever seen me use the word polynomial yet?
No.
No. So don't put stuff in there that's not things we've covered. Right? Don't put stuff in there that we haven't covered yet. I'll get there, but that's not something anyone should be studying because we haven't covered it yet. Use your notes. Use your resources. And if you don't have the information, instead of going online and going to Google and seeing a whole bunch of things we haven't covered, where could you go find the information?
YouTube.
Huh?
YouTube.
YouTube, right? Don't watch the whole video, but if you're looking for information about quadratic functions, couldn't you go to just the whole class discussion, 20, 30 minutes about quadratic functions? And you're going to get exactly what I told students about. You can skip around, things like that. Okay, so be aware that that is there. So we should each have out our linear and exponential equations sheet. Does anyone not have a copy of this task or this problem, set of problems I passed out yesterday? Okay, Haley. Anybody else not have this? You probably got it from the sub on Friday. Anybody else? Okay. Who? You need one too, Z? That's not it right there on the right? Is it? Yeah, that's it right there. Hey, are there any extras of those on desk? I saw some on the desk earlier, just so I can give one to Haley.
I saw one too.
No extras? Okay, I'll just print it out quickly.
Why did you take it?
opinion.
I'm saying that's a real person. You watching me?
I was talking.
I just asked you.
Okay. Can I get someone to read our first objective for the day?
I'll read it.
Thank you, Jamarcus. What is it?
I can identify linear and exponential functions.
Hold on. Hey, Phoebe, what did Jamarcus just say? Jamarcus, can you please read that again so everyone can hear you?
I can identify linear and exponential functions.
Tomorrow, you're going to have an understanding check not just on linear and exponential, but identifying linear, exponential, and quadratic functions. So this is really good practice for those two types of functions. Second objective, somebody else please. Eliza, go for it.
I can write the equation I can write the equation of a linear function.
Okay, we covered what those equations are. We need to be able to write those equations. Last one, Naisha.
I can write the equation of exponential function.
We got to be able to write the equations of exponential functions. Pay attention to that format, okay? Yesterday, we did talk about number 1 already, I believe. Does that sound right? Okay, so we're already done with number 1. When we go back to our groups at the boards, we're going to take about 20 to 30 minutes to write as many identify as many types of functions as possible and to write those equations. Yes, Lily Kate. Number 2 is the table, the second table. This one? Isn't that number 2? Oh, this number 2. Did we already start talking about this number 2? Okay, it was exponential. Okay, so if you're going to claim exponential on an assessment, what should you note here? You're going to look at the what? The y values. What do you see happening in those y values? Be careful about that, right? I see, and you can actually see it from third block right there. First off, you see where it says exponential, correct? And they say y equals 2. Where are they getting that very first 2 from? The y-intercept, 0, 2. So they're starting at a 2. But then what are they doing to that 2? Over there. They added. Is that what we're supposed to do with an exponential?
No.
No. We're supposed to multiply, right? So we want to recognize that right away. And they're multiplying by what?
1/2.
Are they?
No.
They're trying to multiply by 2.
I thought you were supposed to multiply by 1/2.
Yeah, it ain't gonna work like that.
We got to pay attention. They were going in this direction. Notice going from the positives to negatives. They're actually going backwards, which is why they're seeing times 2. You have to work from left to right in your x values. So you have to go this direction. So for the y, I need to go this direction. What am I doing to 16 to get to 8? Multiply by 1/2. Multiply by 1/2. And I will remind you and point this out, many of us be tempted to not say multiplication, but to say that we are dividing by 2. That's why I wanted you to practice writing this fraction, because what is this literally saying? 1 divided by 2, right? This is rewriting that division as multiplication so that I can use this exponential equation here. Okay, so we are now through number 2. Any questions before I have you start going to your small groups? Starting with number 3.
Wait.
This is added 4.
Heard someone say something.
Oh, I did it.
Alright, so what am I going to have to do to fairly figure out who gets the TV? Yeah! Let's look at the random number generator. So random integer 1 to 7. The TV is going to group number 3. You get to work on the TV today. The chalkboard is going to group 7 and group 2. So group 2 and group 7. You get the chalkboard, group 3, TV. Let's go groups 1 and 4 on this whiteboard, which leaves me with 5 and 6 on that whiteboard. Alright, let's get up, let's get moving, let's start working on number 3, and let's get all the way through this in the next 30 minutes. Max. Actively collaborate, talk with each other to grow and to learn. I want to go ahead and address it since I see it popping up right now. I do want to point this out. Once you write an equation, each input should give you the same what? Output. So when I look around the room, one of the things I saw pretty regularly, I don't see it still up anywhere, but with number 3, I saw this. Y equals 2x plus 1, or even 1 plus 2x. Here's the issue with that information though. Let's say we substitute the number 3 in. What should I get out? 6. Put it in though. What is 2 times 3? 6 plus 1? 7. You see how that does not match the inputs to the outputs? We should always be able to put our inputs in and get our outputs out from our equation. So pay attention again to that equation. I think the majority of us are getting that 2 and that 1 because we see the y changing by 2, right? And what's the x changing by? But notice how I just said the x is changing by 1? So that 1 is a part of my rate of change. That 1 is not part of the, so we say y equals mx plus b, right? That 1 is not the b. What do I mean by that b right there in that equation? That's my what? That's the y-intercept, isn't it? What should we know about every y-intercept that has ever existed and will continue to exist? There's one thing we have to know about the y-intercept. Say it again, David. That x is going to be 0, guys. You can see it graphically. I've put the graph a couple of places. Notice, here's my y-intercept where the function intersects the y-axis. That's right in between an x value of -1 and an x value of 1. Hey, what number's right in between -1 and 1? 0, right? The y-intercept always has an x value of 0 for that reason. And I'll point this out. I draw this because this is how I eventually learned how to determine what the y-intercept is. It was never by memorizing because I constantly messed up what was supposed to be 0 with x and y-intercepts. It was by drawing it and identifying that relationship graphically that I was like, oh, if I want a y-intercept, the x has to be 0. That's what I was able to visualize to make sense out of it, and I was able to keep with it. So notice none of this is my y-intercept. I need an x value of 0, so what's the y value here? If I need that x value of 0, what's this y value? That's what keeps my pattern alive. And remember, so that would be a plus 0 here. How do we calculate slope? How do we calculate slope? Rise, divide by run, or delta. Okay, let's pause for a second. Now, let me point this out. You say rise, right? Which variable is changing if you're rising? The y. So it's the change in y. That's it. If you visualize rise, it's the change in y. And if something is running, it's the change in the x. That's it. Notice the change in y is 2, the change in x is 1. So that slope is 2. Now if I substitute numbers into that equation, what's 2 times 3? 6. What's 2 times 5? 10. Every input maps to the correct output now. When you write the equation, the input should map to the output. And all I mean by that is, when I substitute this input in, I get this output out. Now, with that information, some of y'all need to go back and look at number 4 again. Okay? Some of y'all, when you go back to your group, to your vertical surfaces, need to look at number 4 again, and then let's pick up from there. One thing I will remind you is this. If you're struggling on a table to write the equation, what else could you have created? Could you have quickly sketched out a graph? I bring that up because when I look at something like number 5 or number 6, if you're struggling to identify the rate of change, what could you create in number 5 to identify it? A table? In number 6, where you have that verbal representation, could you make a table or a graph? Don't forget, you don't have to stay looking at that representation. There are options, and take advantage of that. What are your questions before I have you go back to your small groups? Or to your vertical surfaces? All right, let's go get to work. Job harder than it has to be. As soon as I look at number, what is this, 5 here? Eyeballs and ears. Eyeballs up here, ears right here. As soon as I look at number 2, I should recognize this as what type of function? Exponential. Do you know what the next thing you should do if you're trying to, oh, first off, do I need to clarify exponential? Are we good with that? Okay, it's exponential curve, it's exponential. As soon as I say, hey, it's exponential, if I'm trying to write the equation, what should I write down? This shouldn't even have to be a second thought, we should immediately write this down. I'm trying to write the equation for an exponential function.
X equals A times bx.
Oh, raise the x?
Raise the x.
Okay. Does anyone want to push back on that equation or ask a question about it? Nope, that's right. Okay. Notice, guys, that's not the final answer, but if I say it's exponential, I'm going to write out the exponential equation immediately. Immediately. Because it's going to help me focus my attention. But we need to know what these letters that we're going to fill in mean. When I say A, what does that mean? What does this A stand for? Which intercept? The y-intercept. Notice how many times is that A there? It is there once. That means it's only there one time. So I can actually see that y-intercept from my graph very easily. What's that y-intercept? 2. I bring this up because I saw at least one group who got very close on this one. I don't remember where it was. Here, right? At least I saw that one. And they have 2 to the x, but do they have the original 2? We've got to pay attention to that we have this. And notice if I write this equation out, it helps me focus my attention on identifying that y-intercept. Then it's times, and we need to identify the b there. Times 2 to the x. Okay? So remember, if that is my equation, each point should make this equation what? True. This point right here is 1 comma 1, 2, 3, 4, 5, 6. So does 6 equal 2 times 2 to the first? Notice I substituted 6 in for y, 1 in for x. Is that a true statement? Is it 3 there? Would that be true? 3 to the first is 3. 2 times 3 is? So we're now thinking that this should be a 3 maybe? Now I don't want to have to guess and check, but let's check this. 2 comma, I believe this is 18. So would 18 equal 2 times 3 squared? Right? 2 is taking the place of x. 18 is taking the place of y. What is 3 squared? 9. 9 times 2 is 18. That's reasonable. That's working. Now I want to pause though, and I want to point this out. I already saw some students doing this. Don't do this. But they did this. Plus 4 to the right 1. And so they were tempted to do this right here. But what is this referring to, that 4 and that 1? That is my slope. But is this linear? Nope. Notice it doesn't go up 4 to the right 1 again. So don't use slope with exponential. What would have helped and made this easier is look right here. What did this group do? They made a table. And what's 2 times 3? 6 times 3? 18. Now we do want to note that the x is changing by 1. And so that quickly identifies that my constant factor, my constant multiplicative rate of change is times 3. Now we need to check that y again. Because there's no way it's a negative 1. Because what's negative 1 times 3? Negative 3. If I'm going backwards, like going this direction is times 3, right? Going backwards then would be dividing by 3. So this would be 2 divided by 3, or 2/3. That would be the correct initial point there. You didn't need that, but we do want to notice, right? What's the easiest way to identify that rate of change with an exponential? Is it off a graph? Nope. Can you? Sure. But it's much easier off that table. the way you could have done it off the graph is you would have to look at the points. Look at those points. What's happening? You go from 2 to 6 to 18 times 3. We would want to notice, like, you can do it off of the graph, but it's easier off the table. You would just have to remember, hey, it's exponential, so I'm repeatedly what? Multiplying. Because I'm repeatedly multiplying, I got to look for something to multiply through each time. What are your questions about number 5? How many of us have gotten to and finished number 6? Okay. So we need to get back to our groups. I'm going to go ahead and tell you we're at 9:11. Sorry, we're not going to get to the book today. I definitely plan to, but it's sounding like we need more practice with writing these equations. Okay. So we are going to, now hear me very clearly on this, guys. We have been working for 40 minutes and we've gotten through 2 or 3 equations. We got to move more quickly. The way we do that is we focus on, as soon as we identify the function, what should we write down? The equation. Use that equation to drive what you're thinking about. What is my y-intercept? What is my rate of change? We got to move more quickly though, alright? So, let's go, but are there any questions before we go back to our vertical surfaces? Alright, let's get up, let's get moving, let's get talking. There's been better active collaboration today, but we got to get to work. Yes. Have you made it? Did you make a table yet? Okay, so if you're now one thing I'm going to caution is don't use the x for multiplication, use the dot. But could you go backwards? So yeah, let's talk about this as a group. Alright, go ahead. So David was asking right here, and we do want to recognize I'm not going to use that whole x, right? Times. So if I'm going to go backwards, right? I'm just using the dot instead. Yeah, 1, 2. So then if I'm going to go backwards, what's that line of it? Because I need to move this direction. If I'm multiplying by 2 going this direction, I need to divide by 2 going backwards, right? So it would be not 1 over 2, just because I'm dividing 2 by 2, which gives me 1, right? Now again, this is what type of function? Exponential? Do you see the issue you made? Or the issue you ran into? Yeah? You can't add right there. And this shouldn't be a 0, it should be a 1 times 2 to the x. That's why we write out this equation to get started. Because I get it, a lot of people put plus here because we're used to a linear equation. But if it's exponential, write that out. It's going to help you not make that mistake. Alright, let's get back to work. Let's continue. Here's your homework assignment. I am about to give you every single one of the following equations. I want you to be successful and pass my class. I want you to learn some mathematics. So, no one joking
I'm trying to go into
it. It's actually take care of. So shut it down. You have time during enrichment to knock it out every single day. So,
I don't care about none of this.
What you said? I'm not What you said?
I'm about to give you the equations so you don't have to sit there. So Quan, Petway, and KP.
I ain't gonna say nothing, man.
Come on, man.
Dude, you recorded.
So,
And he did do the
please stop. So, I'm going to give you the equations. Your job is to come up with and explain where the values in the equation came from. Okay? So I'm already going to go ahead and give you the equations.
Wait,
you don't have to struggle to get the equation. Your job is to figure out where did that equation come from. So the equation here is y equals 1 times 2 to the x. That's number 6. So I'm already telling you that's the equation. You need to figure out why that's the equation, Petway.
My paper bill.
Okay. Then take a picture in a second.
Okay.
How about take a picture of my phone?
We're about to end class if you'll quit interrupting me.
Please.
Yeah.
So, my point is, we should recognize if that's the equation, then you probably need to look for what type of function?
Exponential.
We should recognize, okay, there's exponential, there's repeated what? Multiplication by 2. So
By 2.
your job is to look at the representation given and come up with where these values coming from. Okay? Number 7. Number 7, Erica's worried about her secret, that her secret got out. She and her best friend were the only people who knew about the secret, but each day 2 new people hear about the secret. Y is equal to 2x. Number 8. Here we have a graph. Y is equal to 1 times 2 to the
I can't
x.
even see.
Times 2x.
2 to the x. Oh, 2x for number 7, yes. We have a linear function.
Come back to my seat. I can't get my head. Then I struck a pose for your YouTube.
Correct. You struck a pose instead of just crossing back and sitting down and doing what you're supposed to do.
But I want to be TikTok, YouTube famous.
Number 9. I messed up on this one. Don't do it. I will point this out. It's what type of function? Linear. Can you tell clearly what that y-intercept is?
No.
See how it's not on an intersection order? So you would have had to use, it's not exactly, you would have to use point slope on this one, and we haven't been over point slope form of a line yet, so don't do it.
Okay.
Number 10,
We ain't doing number 9.
No. What's this do?
Thursday.
Okay, cool.
So we got.
Number 10, okay? We have this situation with a family pool, holds 1,500 gallons of water, and this person's trying to fill up the pool,
Okay.
right? Check the flow of the hose, found it was filling the pool at a rate of 2 gallons every minute. When I had 5 gallons of water in the pool, I started the timer. So y equals 5 plus 2x, or you can do it as 2x plus 5 either way. And again, remember, especially with a word problem, right? Janaya said it, and I understand. We don't love word problems. Do you have to keep this as a verbal representation? No. Make a table or make a graph to make more sense out of it. Finally, number 11, Jiminy Cricket is 3 feet away from his house when it starts to rain. As more rain falls, Jiminy can't jump as far. On his first jump, 1.5 feet or half the distance to his house. Each jump after that, Jiminy can only jump half the distance of his previous jump. So we have with number 11,
Y equals 3x times 15x. I mean, not 15.
y equals 3
1
times
half.
1/2 to the x.
I was right though.
Okay.
Bro, say I was wrong.
You said 15, my guy.
I meant 1/2. That's what I meant to say, dude.
How do you
Hey,
get
none of y'all-
1/2 from 15?
Because it say 1.5 and I seen it to get, dude.
But
Ain't none of y'all trying to deal. What is y'all talking
Quit,
about?
guys.
Oh my dad, nigga.
language. Hey, I'm gonna tell you this. I don't care what color you are. You say the N-word in my class, it's a write-up from here on out. We don't use that term. It's derogatory. We're not using it. So,
Oh, I'm on camera. See, y'all got me out of character. This man was corny clear.
so your homework is to explain those equations. This is what we're gonna get to tomorrow. Okay. Please remember what do we have tomorrow in class?
Probably
Understanding check.
It's an understanding check. Hey, listen. Can you stop talking? We've got 30. You'll have 30 minutes tomorrow. I think it's 13 or 14 different functions, and you have to identify what type of function it is.
Do we gotta?
Make sure you read your directions. Do we have to explain?
Yes, sir.
Yes.
Bro.
Hold on to your Venn diagrams to study. You'll turn your Venn diagram in on Thursday. Notice the direction.
Shit.
Don't touch me.
That was him.
I might not even make it.
Sorry.
I like your hair.
Can I get my calculators put up, please? One person.